Hello, folks. Today we're going to be talking about the prisoner's dilemma as well as the role of cooperation in game theory. So, right off the bat, you might be wondering, what is the prisoner's dilemma? Can it be solved? Well, the prisoner's dilemma is sometimes referred to as a thought experiment, and on top of that, different outcomes do have different payoffs for those involved. It's worth noting that the payoffs for one party are dependent on the other's choice, and in short, we know that this is a strategic interaction because the payoffs one receives are partially dependent on the other's choice. Now, that's a lot of words to take in, so let's put it in a way that might be easier to understand. So right here, we have two parties with two options, and there are therefore four possible results, each represented by a cell. Each result is dependent on each party, since the outcome can't be made by one party alone, and then we know that it's a strategic interaction. So see those check marks? Remember where they are, because they're really important for a phenomenon called Nash equilibrium. So Nash equilibrium happens when both parties choose their best response, and it's determined by a thing called the checkmark method. So it's worth noting, though, that in the context of a prisoner's dilemma, a Nash equilibrium means cooperation didn't occur, and even if everyone picks their best response, the equilibrium outcome isn't necessarily the best one. So back to those check marks from earlier, you can see here that they showcase the best response for both parties, which happens to be defecting. That means when both parties defect would be when Nash equilibrium occurs. So now that we know what the prisoner's dilemma is, how do we solve it? Let's go through it together by mixing together what we know and putting it into action in the context of an example. So I have a younger brother and sister, and this week I wanted to try out the prisoner's dilemma thought experiment on them in the context of chocolate bars. I told them both I could get them some, but that they might need to give up their share for the other. I didn't say anything about how much they'd get in either case, if at all. So step one is to construct a table with the payoffs, which I've done here. So within this table I've made, you can see 4 cells, and in each cell is the payoffs my brother or sister would receive in each scenario. Step 2 is to think about the what ifs, and this can be tricky, so to make it easier, we're going to employ the checkmark method. So as you can see, I've added check marks to certain decisions, and no matter what the other sibling does, it is better to defect rather than cooperate. Cooperating opens the chance for no chocolate bars, whereas with defecting, at minimum, they'd each get one. Step 3, then, is to play the best option once you've identified it. And based on our evaluation, we can conclude it's the last step. So note that this is also the Nash equilibrium, being when they both defect. So we solved an example, but what's this got to do with economics itself? Well, the prisoner's dilemma is relevant to economics because from chapter 1 we can recall that economics is a way of thinking. Therefore, game theory is relevant, as is the prisoner's dilemma and other strategic interactions. Different demographics may behave differently, so having technical methods for decision making can be efficient, especially in an economic context. Thank you for watching, and have a great day. Here's my sources.